Have you ever tried to find someone's longest streak of daily activity from a messy log? That's exactly what LeetCode's longest consecutive sequence asks. One of the Pattern Mastery 100 essentials, and a problem that stumped even experienced engineers at companies like Google, Netflix, and Facebook. In interviews, getting this ON trick is a game changer. Let's apply the basic approach. A strategy broader than STAR because it's designed for breaking down technical challenges and system designs, not just behavioral questions. We're given an unsorted array of integers and asked, what's the length of the longest run of numbers that appear consecutively, regardless of order? For example, 100, 4, 200, 1, 3, 2, yields, 1, 2, 3, 4 length, 4. Edge cases? Handle empty arrays, negatives, duplicates, anything the interviewer throws at you. Suppose you're designing a fitness app. You get a list of dates a user logged workouts. How do you instantly show their longest streak, no matter the order the logs came in? This problem is exactly that challenge. If you sort and count, you get ON log n. Good, but not great. The best solution uses a hash set for O1 lookups and only starts streaks at the true beginning of each run. Num, 1 isn't present. That way, you never double count or waste work, making the algorithm ON. Add all numbers to a set so we can check for any number in constant time. For each number, only start counting a sequence if there's no smaller number in the set. Count up from each streak start, tracking how long the run goes. Update the max streak found along the way. Return the result. Let's walk through the logic as if we're coding together. Let's try to implement it using solution 1. Time complexity. ON log n. The concept discussion. The goal is to find the length of the longest run of numbers that go up by 1 each time, like 4, 5, 6, 7. This solution does it in 2 big moves. Remove duplicates, because repeated numbers can mess up counting a clean consecutive run. Sort the numbers, so any consecutive sequence will appear next to each other. Then we do a simple linear scan. Keep a current streak counter while numbers stay consecutive, and whenever the streak breaks, we update longest and reset current back to 1. This function cleans the input, sorts it, then walks through once to measure the longest consecutive streak. First, we handle the simplest case. If there are no numbers, there can't be any sequence, so we return 0 right away. Next, we remove duplicates using a set, then turn it back into an array and sort it. This is super important because once the numbers are sorted, any consecutive sequence, like 10, 11, 12, will appear right next to each other, making it easy to count. Now we set up 2 counters. Current tracks the length of the streak we're currently in. Longest remembers the best streak we've seen so far. We start both at 1 because a single number is always a consecutive sequence of length 1. Here we walk through the sorted array from left to right. If the current number is exactly 1 more than the previous, we're still consecutive, so we grow current. If it's not, the streak is broken, so we compare current with longest, update longest if needed, and reset current back to 1 to start a fresh streak. Finally, we return the best streak length. We take math.max longest, current, because the longest streak might end at the very last element. So we do one last comparison to be safe. And that's how this algorithm works. It first removes duplicates and sorts the numbers to line up any consecutive runs, then it scans once to expand streaks when numbers increase by 1 and resets when the streak breaks while tracking the best length. Efficient, simple, and elegant. Let's test our function using this input array. 100, 4, 200, 1, 3, 2. These numbers are unsorted, and we're trying to find the longest streak of consecutive integers that appear in the array. Since this solution uses sorting plus a linear scan, the first thing it does is remove duplicates with a set, then it sorts the numbers. So the array effectively becomes 1, 2, 3, 4, 100, 200. Now we scan from left to right. 1 to 2 is consecutive streak becomes 2. 2 to 3 is consecutive streak becomes 3. 3 to 4 is consecutive streak becomes 4. Then 4 to 100 breaks the chain. So we lock in that streak length of 4. Nothing later beats that, because 100 and 200 are isolated. And that's exactly what our program outputs, 4. That output makes total sense because the longest consecutive sequence here is 1, 2, 3, 4, which contains 4 numbers. So, our implementation is correct. The algorithm successfully finds the longest consecutive run by sorting once and doing a single clean pass, efficient and accurate. Let's try to implement it using solution 2. Time complexity. ON. The concept discussion. This solution avoids sorting by using a hash set for fast lookups. The key trick is, we only start counting a sequence when we're at the beginning of that sequence. How do we know we're at the beginning? If num1 is not in the set, then num must be the first number in its consecutive run. From there, we keep checking num plus 1, num plus 2, and so on, growing the streak until it stops. We track the longest streak length across all starts. This function builds a set for fast membership checks, finds sequence starting points, expands each sequence forward, and keeps the best length. First we put all numbers into a set. This lets us ask, does this number exist? Really quickly. We also set longest to 0, because if the input is empty, the correct answer should stay 0. Now we loop through the set's unique numbers. Here's the big efficiency trick. We don't try to build a sequence from every number. Instead, we only start when num looks like the first number of a sequence. After checking all possible starting points, longest holds the length of the longest consecutive sequence, so we return it. And that's how this algorithm works. It first stores all numbers in a hash set for quick lookups, then it only starts counting from true sequence beginnings and expands forward to measure each run while tracking the maximum length. Efficient, simple, and elegant. Let's test our function using this input array: 0, 3, 7, 2, 5, 8, 4, 6, 0, 1. These numbers can be in any order, and we want the longest sequence of consecutive integers that appear in the array. This solution loads everything into a set, so lookups are fast, and duplicates don't matter, like the extra 0 here. Then we only start counting when we find a number that's the start of a sequence, meaning num1 is not in the set. In this input, 0 is a sequence start because -1 isn't in the set. From there, we walk forward. 0, 1, 2, 3, 4, 5, 6, 7, 8. That's a continuous chain of 9 numbers. Other numbers like 3, 4, 5, and so on don't start new scans, because they do have a previous number in the set, so we avoid repeated work. And that's exactly what our program outputs: 9, matching the expected result. That output makes perfect sense because the longest consecutive run is 0 through 8, and that sequence contains 9 elements. So, our implementation is correct. The algorithm efficiently finds the longest consecutive sequence by only expanding from true sequence starts, fast and accurate. Alright, quick recap to wrap up longest consecutive sequence. Here we're given a bunch of unsorted numbers, and the order doesn't matter at all. The goal is to find the length of the longest streak of consecutive integers hidden inside that disorder. And importantly, we're returning the streak length, not the actual sequence. We started with the obvious idea. Sorting would work, but it costs O(n) log n. The better insight is using a hash set for fast lookups. Then the key optimization is this: we only start counting when we're at a true beginning of a sequence. A number is a sequence start if its predecessor is missing, meaning num1 isn't in the set. The plan is clean: put every number into a set. Then for each number, check if it begins a streak. If it does, expand forward, num plus 1, num plus 2, and so on, until the streak breaks. Keep track of the maximum streak length we ever see. We built the set once, skipped numbers that clearly have a predecessor, and only expanded from true starts to avoid repeated work. The solution ran cleanly on LeetCode with no errors. We validated across tricky cases, duplicates, negative numbers, scattered inputs, and it still works without sorting. It also behaves correctly on empty arrays and single-element inputs, and all test cases passed. The real trick isn't counting faster, it's starting fewer times. Hash set lookups plus start detection turns this into an O(n) solution. Master this pattern, and a lot of array problems start unlocking.